Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris Hakimi bin Muhammad Najib. Metric number 223038889. So I will present about the chemical consequences modeling, which is my individual project. So the tactical safety dashboard, which is the baseline site of configuration and chemical input, the site metadata facility is PCFK Cogen Plan in Gurun, Kedah, Malaysia. So the software I'm using is Aloha Suite version 5.4.7, and the core objective is quantitative consequences modeling and plum analysis. So the label container design, which is what I show here, is liquid storage under vapor pressure baseline, and the liquid temperature is 28 degrees Celsius from the 10 cm bottom shell leak punch. And waste management, this is the waste management flow chart, and step 1 is a scrubber neutralization, step 2 is effluent treatment, and step 3 is regulatory compliant discharge. And this is the GHS standard hazard label for toxics and oxidizer and corrosive, which is danger, and the hazard segment fatal if inhaled and may cause severe respiratory irritation and skin chemical burn. So the significant consequence modeling and critical incident profile, which have appear here. Scale plum footprint graphic, which is this is the source for ammonia, propane, and chlorine, and then the critical threat is present for chlorine. The critical threat is present immediate life-threatening, and physical behavior is gravity drift. Heavy gas dynamic trap the dense plum along structural corridor. And for ammonia, which is a toxic and corrosive, the plum reach red, orange, yellow, and then the critical threat is massive high rate leak crosses boundary lines, causing several respiratory and skin irritation. For the physical behavior, mist pool formation, rapid evaporation, creates a cold, dense, stationary cloud that spreads outward. For propane flammable, which is a vapor cloud, and the critical threat is severe secondary ignition, risk near structure assets, physical behavior near field patchiness, high density eddies require strict safety clearance. So the synthesis call out about, which is key finding for safety team. While toxic chlorine vapor travel the furthest distance, ammonia's two-phase aerosol flow introduce the highest source point mass. Meanwhile, propane creates a severe explosion risk near critical plant infrastructure. For the active mitigation strategy and emergency response framework, so the first one is engineering, which is engineer mitigation system, which is first automate feeds water certains installed around ammonia and chlorine tank containment base, and then action dissolve vapor clouds and dilutes aerosol concentration, and then remotely operate shut off valve link directly to optical gas sensors, and action close line feeds in under 50 seconds to prevent a major release. And for gas detection arrays, dedicated electromechanical sensors placed upwind and downwind. In action, instantly alert control and operators for yearly area clearance. And this is the tactical incident response for this, which is the what we call human action. And the human action, wind directed evacuation route and shelter in place protocol. If a release occurs, personnel must immediately evacuate. Then for structure in outer yellow zone, take advantage for the facility low baseline building air exchange rate, ceiling window and cutting HVAC. Provide effective protection against a short duration 1 minute release. And that's all from my presentation. Thank you.